In this video, we're going to talk about overloading methods. So in the previous video, I said that we could overload the constructor. And what I meant is that you can create two or more versions of the constructor so that the client code can choose which constructor it wants to use and how it wants to go about the process of constructing a new instance of an object. A constructor is just a type of method, right? You can create overloaded methods, overloaded constructors we'll talk about later, but overloaded methods, each with a different method signature. Do you recall yesterday when we talked about the difference between method signatures and method headers? Well, we're revisiting that topic right now. What we want to focus on is method signatures. We're not worried about the name of the parameters, just the data type of the parameters, okay? So I want to demonstrate how we can create overloaded versions of our methods within our classes, and then I'm going to explain why in the world you'd even want to do that. Okay, so let's take a look at a simple method that we're going to call drive. We're going to put it on the auto class. So here is the first version of drive, public void drive. We're going to accept no input parameters. So that's one implementation. Now I'm going to create 3 additional implementations as well. Okay, so as you can see, I created 4 different versions of the drive method. They all have the exact same name. The only thing that's different about them is what we're passing into them. And we'll establish the point in just a moment about method signature versus method header. We'll come back to that in just a moment. All right, so semantically, each of these instances of the drive method are just a little bit different, right? First, the drive method that takes no parameters, it implies that the car object should just keep going and going and going until perhaps the corollary to the drive method, the stop method, is called by the client code. Okay. The second one that I have highlighted right here in line 29, it implies that the car object should drive a certain number of miles before stopping by passing in the number of miles. The third implies that the car object should drive until it reaches a certain XY coordinate. And then the fourth implies that the car should drive until it reaches a named location, such as Dallas, Texas, or Seattle, Washington. Okay, so let's take a look at how this is implemented then within our program.cs class. Let's focus here on our line 27 where we're creating a new instance of our auto class. And here I want to use mycar.drive. And notice when I hit the open parenthesis and get it IntelliSense that I now have, using my arrow keys, 4 implementations of the drive method. It shows each of the 4, and I can choose as the consumer of the auto class which of these overridden versions of the method that I want to use. Overloaded versions of the method that I want to use. So in this case, I might just say drive 5 miles, right? And so now I have the ability to drive 5 miles, and I've used one overloaded version of our method. So let's see this. If I run it, it's not going to do anything because we didn't implement anything in the body of those methods. So we'll just pass on that for the moment. But the key idea here is that we can give different semantic meanings to the same method, giving the consumers of our class and of our method choices on how they want to call the method. They may not have all of the data available to them to call one version of the method, but that's okay because you, as the builder of that class and method, can allow for different implementations that essentially accomplish the same thing. They all drive. They just do it in a different way. So that's semantically what we're trying to get across here. You might call on a person the talk method and then pass in which language that you want to speak, or maybe you don't care what language that they speak as long as they express themselves. A lame example, okay? You get the idea, hopefully. All right, so let's go back to the auto class and drive home one point. If I were to create, for example, a public void drive, and here we're going to go int distance, and then int speed. All right, that might be another way that we can implement the drive method. When I go to build this, we're going to go to debug, build solution, or hit F6 on our keyboard. We're going to get an error message that says it already defines a method called drive with the same parameter types. So we get some sort of an ambiguity error. The problem is that we have two methods with the exact same signature. Even though the header is different, the name of the parameters are different here. I'm not using location X and Y, I'm using distance and speed. The signatures are the same, and so our application won't really know which version that you are trying to call whenever you pass in two integers. All right, so basically, how can we solve this? Well, we either need to change the parameters to the drive method in one of two of these cases, or we need to create a different method and not name it drive. So drive based on distance and speed. Okay, we could do something like that. And that's perfectly acceptable. It might be something you have to do if you have some collisions with the number of properties that you, or number of values that you expect to accept into the drive method. Okay, so to tie up a loose end now, let's go back and talk about the implementation of an overloaded constructor from the previous video. So let me delete that first of all, and then go back up here to our auto constructor. So what I might do is this instead, or in addition: public auto string make string model. Notice that I'm using an underscore character. Sometimes developers do this when they've already used an underscore to denote a private field. Here I can't reuse make because this line of code wouldn't make a whole lot of sense. I think even C# compiler would have a problem with that, right? I can hover over and it says, huh? Assignment made to the same variable. Did you mean to assign it to something else? So that's why sometimes in input parameters, I'll use an underscore like that, okay? Or I could give it a whole different name. Auto make or auto model. Here we'll just go with the underscore for the moment. And then model equals underscore model. All right, so what did I accomplish here? Well, now, whenever we go to our program.cs, let's go ahead and delete that. And I go to create a new auto. Let's just rewrite this line of code, okay? Auto my car equals new auto. Now I get two versions of the constructor. So I could pass in the make, Toyota, and the model, Prius, or whatever. Okay? And that would work just fine. And now I've initialized the state of my car object so that it could be usable for the rest of the application. I put it into an initial state. Okay, so that's all that I wanted to get across here. We talked in this video about overloading, and you can get those mixed up. You heard me do it, overriding versus overloading. Think of the difference in your head. When I'm overriding, I'm covering up. I am changing a base class's implementation. When I'm overloading, I am giving more than one implementation of a single method that the consumer can choose which of those overloaded versions of the method to actually use within their application. Each perhaps just a little bit semantically different, each with a slightly different implementation that basically accomplishes the same thing. Okay, so that pretty much covers overloading both regular methods and constructors. With that, we'll see you in the next video. Thank you.